Okay, so we're ready to start chapter 9. If you go ahead and take a look at your textbook, chapter 9 says solving quadratics and inequalities. So hopefully we'll get through the at least the first half of chapter 9 and get through all the quadratic solving work, and then possibly we'll get to a little bit of solving inequalities, hopefully. Okay. All right. If you can find access to a printer, or you have access to a printer, go ahead and print out this worksheet that goes with 9.1.1. If you can't, you can go ahead and just get out your own paper and work through some of these warm-up problems, okay? All right, so the first question asks you to solve these equations by using the zero product property. All right, so I'm going to go ahead and try the first problem here. See if you can solve it using the zero product property. Okay, so remember the zero product property says that if you're multiplying a number of products together and or a number of factors together and their product is zero, that at least one of those factors has to equal zero. So you're looking at, if I want to solve x, what would have to make this factor zero? Well, x would have to be 5. What could make this factor equal to 0? Well, I just have to figure out 2x plus 3 equals 0. So if I subtract 3, I get 2x is equal to negative 3. Divide by 2, so x would be negative 1.5. So I've got two possible answers for this quadratic. There's 2 times that this product would equal to 0, either if x is 5 or negative 1.5. Okay, I want you to go ahead and try and solve the second one. Okay, so what strategy did you use to solve the second one? Did you just kind of give up and go back to the old balancing method, or did you try and write this in factored form? Remember, if I try and balance this out and get my x alone, I'm kind of stuck with this squared and this x here. So I get kind of lost at what I'm supposed to do to be able to figure this out. I mean, I could keep going and I could divide both sides by x and get x is equal to negative 6, which would give me one solution. But if you're sort of short-sighted and do it that way when you save a quadratic, you're actually going to probably lose a solution. Okay, so let's look at if I were to factor this. Okay, and there's a couple ways of factoring it. I could go ahead and do the generic rectangle and the diamond, but since these both just have a greatest common factor of x, I'm going to go ahead and write this as x times x plus 6 equaling 0. So x is either equal to 0, or what would make this factor 0, x would be negative 6. Okay, so if you start to balance, even though I didn't get stuck because I didn't have a constant term that I was kind of dealing with too, you end up losing one of your answers if you do it that way. Okay, so generally when you have a quadratic, that balancing method is rarely going to work. So you need to think of some other strategies, okay? Which one of those is using the zero product property and trying to factor. Okay, so give the third one a go. Okay, now don't forget it says zero product property. What's our problem here? Okay, even if I try and factor this over here and it equals 9, that's not going to really help me. Okay, if I've got 9 equaling, say, 2 things multiplied together, does that help me figure out what one of those 2 things is? No, because I could have an infinite amount of things here. This could be 1, and this could be 9, this could be 18, this could be 0.5, this could be negative 1, this could be negative 9, an infinite amount of things. Okay, but if I've got it equal to 0, now I know one of those 2 things has to be 0, okay? So one thing you've got to remember is that in order to use the zero product property, you have to have it in factored form equaling 0, and this equals 9. But no problems. I could get it equaling to 0 pretty easily by just subtracting 9 from both sides. I get 0 is equal to 3x squared plus 4x minus 15. And then I can try and factor from here, okay? So I'm going to go ahead and just do my 3x squared minus 15, negative 45x squared, 4x, negative 5x. So let's see, and 9x to get a sum and product. So negative 5x, 9x. So 3x here, x minus 5. Let's see, I need a 3 here. Okay, so now I'm writing it 0 is equal to, let's see, 3x minus 5 times x plus 3. Okay, so now I can use my zero product property. What would make this factor equal to 0? Well, x would have to be 5/3. What would make this factor equal to 0? X would have to be -3. So those would be my two solutions now. Okay. All right, so at this point, the zero product property is pretty much a strategy that we have been using from kind of what we learned in the previous chapter with just graphing quadratics to help us figure out how to solve quadratics. Okay, so it does say explain how to verify your answers by using a graphing calculator. You could also use Desmos. So I'm just going to go ahead and pop in the first one. Okay, I notice here, when does that equal 0? Well, either at 5 or at negative 1.5. Okay, let's look at the second one. X squared plus 6x, when does that equal 0? I can see that one of the answers was 0. The other one, -6, okay, which is what we got over here. And then let me turn on the last one. So 3x squared minus 4x plus minus 6, when does that equal 9? Now it's a little harder. I could go ahead and just start tracing up here. When does that equal 9? Ooh. Okay, I'm having a little trouble getting exactly on to 9. And then you can tell that if I, kind of trace back this way, I should be able to get a 9 also. Okay, it might be easier just to put in the line y equals 9. Okay, and then just look here. That's going to help me a little better. So -3 was one of my solutions, and my other one was 1.6 repeating is 5/3. Okay, so that's how you could use your graphing calculator to double check that. Okay, so if we know the zero product property seems to work as a way to solve any quadratic. Okay, but let's see what happens. So let's try this one. We've got x squared minus 6x minus 1 equals 0. Hopefully you know to not use the balancing method because of that squared term and that x not being able to be combined. Plus I've got that 1 in here, okay? So I'm going to go ahead and try and use the zero product property. Okay, so I went ahead and put my product here, my sum, and I'm looking for two values that give me a product of negative x squared and a sum of negative 6x. Okay, and it looks like I'm kind of stuck here. Okay, now just to double check here, I would also be stuck if I decided, okay, I'm going back to how I solve linear. I'm just going to start balancing it out. I am also stuck, okay? So balancing almost never works with quadratics. Factoring works sometimes, okay? But I got stuck with both of those. So what else could I do? Can you think of something else I could do to maybe solve this quadratic besides just, maybe I could just go over to a graph and get it, but symbolically just solve this quadratic? Okay, did you think I could try and do what's called completing the square? Okay, just like putting it in vertex form. So I'm going to take my x squared minus 6x minus 1 equaling 0, and I'm going to try and complete the square. X squared here, and I'm going to split this into my negative 3x, negative 3x. So I get x minus 3, x minus 3, negative 3 times negative 3 is 9. I had negative 1 here, so how much am I going to need on the outside? So 9, how do I get negative 1? Minus 10 equals 0. Okay, so I could write this, I could complete the square and write this as x minus 3 squared minus 10 equaling 0. Okay, so a technique that will actually work when factoring doesn't and when balancing, which almost never works, is to try and complete the square. If I get to this point, I should be able to work this out. I'm going to add 10, x minus 3 squared is equal to 10. Okay, so I'm thinking what squared is equal to 10? Okay, so either x minus 3 would equal the square root of 10, or x minus 3 would equal the opposite of square root of 10. Now to get x, I'm going to just add 3 to both sides. So I get 3 plus the square root of 10 as one solution, add 3 to both sides. So 3 minus the square root of 10 as my other solution. Okay, so completing the square will work. Okay, actually every time. Okay, every time. It's just a little tedious. Okay, so if you want to try and solve a quadratic that doesn't factor, go to completing the square. All right, so we're going to practice a few more of those. Okay, so let's try and solve this one by first completing the square. Okay, so let's get this thing set up. I'm going to put my x squared here. Okay, and then you go. Figure out what you're going to do from here to get just this first part sort of set up. Okay, so adjust the equation into a format where you can, the square has been completed. Okay, let's see how you did. Did you put minus 3x here? Minus 3x because I split this guy. So I've got x minus 3x, x minus 3x. Oh, sorry, didn't mean to put an x here. Okay. So I get 9 in the corner. I had 7, so that would mean I'd need 2 more, so I'd have to add -2. Add my tiles. So if by completing the square, this turns into x minus 3 squared minus 2 equals 0. Okay, and now I have a format that is solvable like every time. Okay, so see if you can solve it from here. Okay, did you add 2 to both sides? X minus 3 squared is equal to 2. Okay, now what number squared is equal to 2? Either x minus 3 could equal the square root of 2, or x minus 3 could equal the opposite of square root of 2. I'm going to add 3 to both sides. So I get x is equal to 3 plus the square root of 2. Add 3 to both sides. So I get x is equal to 3 minus the square root of 2. Okay, so those would be my two solutions. Okay, if I wanted to find the decimal approximation for that, I could go ahead and plug it into my calculator and get close. Okay. All right. Let's look at number 5. So solve by first completing the square. Okay, now I will tell you that it's really tricky to complete the square if in this corner you can't start with just an x squared. Okay, we didn't do a lot of those with vertex forms. Actually, really, I think I did one on the closure. Okay, because I figured with us not being in class for me to kind of watch you guys and really help you with that, I thought it might be just a little too complicated. Okay, but what we can do since we're solving this equation, if I wanted to get rid of that 4, I'm going to go ahead and just divide it off. Okay, so I'm going to just divide everything by 4. So I get x squared plus 9x plus 81 divided by 4, 20.25 equaling 0. Okay, so when you're completing the square, it's often easiest if your a value is 1. Okay, now when it was graphing, this was a y right here, so we kind of had to hold on to that 4. But since this is just 0 over here, although we will have adjusted the equation, it'll look a little bit different by dividing by 4. It's still going to result in x being the same thing. Okay, so now I'm going to try and complete the square with x squared plus 9x plus 20.25 being 0. Okay, so go ahead and do that. Okay, so I'm going to stick my x squared here. I'm going to split my 9x into 4.5x, 4.5x. That's going to give me x, 4.5, x, 4.5. Okay, then I'm going to take 4.5 times 4.5 to get the corner, and I get 20.25. Oh, look how nice that is. That's exactly what I had here. So I didn't have any, if I had tiles, they would actually fit in there perfectly. Okay, so that's just going to equal 0. So I'm going to write this as x plus 4.5 squared equals 0. Okay. So what am I going to get as a solution here? So what number squared is 0? Just 0. Okay, so x plus 4.5 would have to equal 0. So I'm going to subtract 4.5, and I get x is equal to negative 4.5. Okay, so it's a pretty tedious method, but you can always solve a quadratic by completing the square. Okay, I will tell you that though, getting rid of the a value first makes it a little bit easier to deal with, because otherwise I would have had to put 4x squared in here. And although that's a perfect square, it's going to get a little bit more complicated with how to fill in the other boxes. Okay. All right. So what we're going to look at next is this kind of crazy, like, what is this trying to show us here? These things right here. This is just, you probably have seen this show up on your homework a couple times. And I know a couple of you guys know what this is already. But we'll really be talking about where this crazy bunch of symbols comes from tomorrow. So just for today, what I want you to do is to look at those formulas, and I want you to put in the values 1 for A, -6 for B, and 7 for C up here. Put it in this one and see what x is equal to, and then put it in this one and see what x is equal to. All right, so I got x is equal to the opposite of b, so b is -6, so I'm going to make it a +6, minus the square root of b squared. Well, b is -6, so -6 squared. -6 times -6, so 36, minus 4 times a is 1, times c is 7, divided by 2 times a, so 2 times 1. Okay, so I get 6 minus 36 minus, let's see, 36 minus 28 divided by 2. So I get x is equal to 6 minus the square root of 8 divided by 2. All right, and then I'm just going to see what that is. Okay, 6 minus the square root of 8. Okay, divide that by 2. That's about 1.59 or so. Okay. All right. So then I'm going to stick it in this one. The opposite of b, so that's +6, and then plus. And then basically I'm going to have the same thing here, except for instead of a negative sign or subtraction sign, I've got an addition sign. So basically 6 plus, it will simplify down to the square root of 8 over 2. Okay, x equaling that. Okay, and I think I'm going to do that in my calculator also. So 6 plus the square root of 8, find that answer, divide that by 2, and I get x is approximately 4.41. Okay, so about. Okay, so I got these two answers when I did this. Okay, wonder what that all means. All right, let's try this formula again, playing around with now 4, 36, and 81. Okay, all right, so I'm going to go x is equal to, let's see, the opposite of b, so b is 36, so -36 minus b squared. So I'm going to do 36 squared minus 4 times a times c, which is 81, divided by 2 times a, which is 4. So I get x equals -36 minus, okay, let's see what all this is. So 36 squared minus 4 times 81. Oh, so minus square root of 0 over 8. So I get x equals -36 over 8, which is -4.5. Okay, well, let's do the second formula. Remember, the second formula is the same as the first one, but instead of a minus sign, there is a plus sign. So I'm going to say x is equal to the opposite of 36 plus square root of, let's see, b squared. So 36 squared minus 4 times a times c, those values, over 2 times a. And I kind of know from earlier that that's just going to be -36 plus the square root of 0 over 8. So I get negative 36 over 8. Okay, I just got negative 4.5. Did I see negative 4.5 somewhere already? Do you remember seeing negative 4.5 somewhere? No. Wasn't that the answer to 5? That's interesting. I wonder what 4, 36, and 81 have to do with 5. Oh, wait. 4, 36, 81? It's kind of crazy. Okay. Wait, then I wonder what 1, negative 6, and 7 have to do with. Hey, wasn't that up here? Wasn't the A value 1, negative 6, and 7 up top? Huh. Do you think these are the same answers as these? Wait, okay, hang on, let's see this. Okay, let's do this. 3 plus the square root of 2. Oh, wait, yeah, that is that. 3 minus the square root of 2. Wait, that's this other answer. So somehow this formula gives you the same answer as that. I wonder what that is. Well, I guess you'll have to tune in tomorrow. Okay, so what you should have gotten out of though today was that you can solve any quadratic. If it doesn't work factoring, balancing's probably not going to work, but you can solve any quadratic by completing the square. It's just kind of tedious, but you should be able to do it.